Okay, we've got a recurring decimal problem here. Let r equal our recurring decimal, which I will write out without the dot. So this is 1.062222, and on it goes. Now, to solve this problem, we will need to move the decimal point such that I get one instance of the recurring decimal on the left-hand side and all of the recurring decimals on the right-hand side. So to get one of the recurring decimals on the right-hand side, I have to multiply this by 10, 100, 1,000. So I can say 1,000R equals 1062.2222, and on they go. So to get all of the recurring decimals on the right-hand side of the decimal point, I need to multiply by 10, 100. So I can say 100R is equal to, and I'm going to put the decimal points underneath each other. So I've got all of the recurring 2's over here and 106 here. Now, if I subtract my lower line from the top line, I will get rid of all of the tail. 1,000R minus 100R is 900R. And this is equal to 1062 minus 106. 1062 minus 106, very quickly in the margin, is 65956. So this is 956, and it's an integer. The tail has gone. So therefore, R is equal to, and after all, R is our recurring decimal number, is equal to 956 over 900. So we need to prove it can be written as 1 and 14 225ths for some really odd reason. Okay, as 956 is greater than 900, I can say this is 1 and 56 over 900. Well, at this point, I'd be very tempted to write, well, this is just equal to 1 over 14 over 225. And it is, because if you divide top and bottom by 4, you will get this answer. And there we are, proved as required.